Okay, so in this video, we're going to be looking at integration by substitution. So this method is used when we are not very familiar with the integral. Like we can't really use the reverse chain rule, we can't use any of the rules which we'll learn later on. Then we can substitute our x with a different variable such as u. In most cases, actually, they'll actually tell you what to substitute with. Like they'll say u is equal to something, and that'll be an easier form. But in other cases where they don't tell us, then we'll also look at how to make our own substitutions. So let's deal with this question here. So we are told that, well, we are asked to integrate the x times root 1 plus x. Now, if we're just given this question on its own, then it'll be quite tricky because we can't really use the reverse chain rule, and there's no trig terms, right? So they've told us to use that u is 1 plus x like this. Right, so what our goal is now is to replace every x with a u. That includes this x here, and also this dx here as well, because dx is technically in the term of x. So a tip that I like to always think of is I always want to, when I solve these questions, I always replace the dx first, because when I do this, some terms might cancel out, which we'll see later on. So starting off with u is 1 plus x, I need to replace this dx first, and the way I do that is differentiate it. So it'll be du by dx is equal to 1, which I can rearrange to say that du is equal to dx, like so. So I'm going to replace that first. It's going to be x times root 1 plus x times du now. Right, next thing is we now replace this x and this root 1 plus x. So going from this initial substitution here, if I was to rearrange it, then x will just be equal to u minus 1. And 1 plus x is just, well, the root of 1 plus x is just the root of u. So this will now rearrange to u minus 1 multiplied by the root of u du. Now we've got everything in terms of u, right? There's no x terms, right? So now we can integrate it, because this is a slightly easier integral. Because I can now expand the bracket by saying this is technically u to the 1, this is u to the half. This will be u to the 3 over 2 minus u to the half du. This is a lot easier for us to integrate now. So this is going to be 2 over 5 u to the 5 over 2 minus 2 over 3 u to the 3 over 2. Don't forget the plus c. Right, so we've integrated it, but this is now in terms of u. The original question is given in terms of x, so we can't forget to replace it back with our x. So all you have to do is just replace the u in terms of x. And as we said earlier, u is 1 plus x here, right? So I can just write it as 2 over 5 1 plus x to the power of 5 over 2 minus 2 over 3, 1 plus x to the power of 3 over 2 plus c, like this. And that's how we do integration by substitution. It's fairly simple if they've given us the substitution to use. Right, let's look at another question. Let's say I want to integrate. Let's go for sine x multiplied by 3 cos x plus 1 dx. And now I'm going to put some limits in as well, because I'm going to say from 0 to pi over 2. And I'm going to say, let's say our substitution, let's u equal to cos x, like this. Okay, so I've given you the substitution to use. So as we said, I would, the way I solve it, I want to replace this dx term first. So I'm going to get du by dx is going to be equal to, just differentiating cos, you get negative sine. And then if I rearrange it, then dx is equal to negative 1 over sine x du. So as I said, I want to replace it first, right? So if I integrate it, I'll be a sine x multiplied by the root of 3 cos x plus 1, and dx is minus 1 over sine x du. Now this is why I replaced this dx first, because as you can see now, this sine x here and this sine x here will cancel out. This doesn't happen in all cases, but it does happen in a fair few amount of questions. So this just makes our lives a bit easier when we have to replace the rest in terms of u. So once they cancel out, then I just replace the rest in terms of u, as we just said. So it's going to be the root of 3 cos x is u plus 1, and there's a negative sign here, so I'm going to take the negative sign outside, du. Right, now we've replaced everything with u. However, one key thing to remember is, unlike the previous example, I've actually given us some limits as well in this question. And so what we have to do is now, these are the limits for x. Because we turned it into u, we have to find the limits for u. So you can't forget this as well. So let's look at the upper limit. So let's say x is pi over 2. So I need to find the u limit. All I need to do is just plug it into our u substitution. So therefore, u is going to be cos pi over 2, which is equal to 0. The lower limit is x is equal to 0. So therefore, u is equal to cos 0, which is give us 1. Now, even though this is the lower upper limit and this is the lower limit, right? Even though the upper limit is smaller than the lower limit, you can't switch the positions around. You have to keep the upper limit as the upper limit and the lower as the lower limit, like this. Make sure you don't switch them around just because one's bigger than the other. Right, now we've done this, we can now we found it all in terms of u. Now we just have to integrate it. So this is now, I can rewrite this as negative 0, 1, 3u plus 1 to the power of a half du. I'm going to have to use the reverse chain rule for this example. So I'm going to say let y equal to, remember we add 1 to the power. So it's going to be 3 over 2. We differentiate it. So we're going to get 3 over 2 using the chain rule. We get this 1 over 2, and then we compare our differentiated one with the original one, with this one here. We don't have this 9 over 2, right? So I have to multiply this by 2 over 9, meaning I multiply this by 2 over 9, meaning this integral here, if I was to bring it down here, it will be minus 2 over 9, 3u plus 1 to the power of 3 over 2, with the limits from 1 to 0, okay? Putting the limits in is fairly simple, so I'm not going to go through that steps, but it's just the main important steps are we have to replace everything in terms of u, including the limits, and then we can integrate it. Alright, so that's fairly simple if they've given us what our substitution is. However, in some questions, they might not give us the substitution, for example, these questions here, in which case we have to actually make our own substitution. So let's start off with question 3a. So they've asked us to integrate x times 3 plus 2x to the power of 5 dx. And they haven't told us what our u is going to be. If we have to make our own substitution, then what you should be really thinking about is what is the harder term to integrate? Is it harder to integrate this x, or is it harder to integrate this 3 plus 2x? Well, obviously it's the 3 plus 2x, right? So that's what I'm going to make my u equal to. That's just a general tip of how to like get about or think about what your u could be equal to. So in this case, u I'm going to set as 3 plus 2x like this. Now it's just a matter of replacing it. So differentiate it first, because I'm going to replace the dx first. We'll get 2, so dx is equal to half du. Okay, and now I'm just going to replace it all. If I was to rearrange this, x is going to be u minus 3 over 2. So this is going to be here, u minus 3 over 2 multiplied by 3 plus 2x is just u, so u to the power of 5 multiplied by dx is half du. Right, we've replaced it all with u, so now we just have to integrate it. I'm going to take the 1 over 4 out just to make it easier, and I'm going to expand the brackets, so it's going to get u to the 6 minus 3 u to the 5 du, which is a lot easier to integrate, right? So this will give us u to the 7 over 7 minus 3 u to the 6 over 6. Don't forget the plus c. And because they haven't given us any limits, it's an indefinite integral, so we need to replace it back in terms of x. So u was 3 plus 2x, so I need to replace that back. So multiplying by 1 over 4, I get 3 plus 2x to the power of 7 over 28 minus 3 plus 2x to the power of 6 over, this is 8 plus c. Okay, so it's fair, as I said, make u equal to the more difficult integral. Right, let's try another example. So let's try maybe this one here, so part 4c. So they've asked us to integrate sine 2 theta over 1 plus cos theta d theta from the limit 0 to pi over 2. And once again, they have not given us our substitution. So we need to make our substitution, okay? So if we're dealt with a fraction like this, once again, we have to think about what are the more difficult term to integrate. They're both fairly simple to integrate, but if we're dealt with a fraction, the general rule is let u equal to the whole of the denominator. Okay, so the whole denominator in this case is 1 plus cos theta. This makes it a lot more easier when we are having to manipulate it. Right, so I've done this now. So once again, I want to replace the d theta first. So I get du by d theta is equal to negative sine theta. So d theta is equal to negative 1 over sine theta du. We also have the limits pi over 2 and 0, right? So I'm going to replace that as well. So let's say theta is pi over 2. So therefore u is 1 plus cos pi over 2. Cos pi over 2 is 0, so this is 1. When theta is 0, then u is 1 plus cos 0, which is given to 0, which is 2. So once now replace it, I'm going to have, remember, even though 1 is smaller than 2, we keep that as the upper limit, the 2 is the lower limit. And then we're going to have 1 plus cos theta and times by minus 1 over sine theta du. Right, this sine 2 theta, I can actually expand using the double angle formula, right? To 2 sine theta cos theta. This is useful for us because now we can cancel out the sines. And from here, we can now replace it with u. So earlier I said u was 1 plus cos theta here, right? So therefore cos theta is equal to u minus 1. So we're going to have limits from 2 to 1 of negative 2. I'm going to take negative 2 outside. Cos theta was u minus 1, and 1 plus cos theta was just u du, like this. Now it's a lot easier to integrate, right? So we have negative 2. I can divide this, so it's going to give us 1 minus 1 over u du. So this is going to have minus 2, and then we're going to get u minus integral of 1 over u is ln u from 2 to 1, which I can just replace into it or substitute into it to get my final definite integral. So that's integration by substitution. So if they give us what the substitution is, it's a lot easier. If they don't, then always think about what is the more difficult term to integrate. And if you're dealt with a fraction, then always make u the denominator, the whole of the denominator. Okay, so in the next lesson, we're going to be moving on to integration by parts. And if you have any questions or any queries, just leave a comment below and I'll try to get back to you as soon as possible.